Morning, everyone. Hope that you enjoyed your long weekend. Your test grades will be in shortly. I noticed that some of you did not take your test, and that's really bad for you. You should, you need to email me, and we need to figure that out because your test grades are worth 90% of your grade. And in order to pass this first quarter, you can't do that without taking your test. So, I appreciate you guys who are keeping up on everything that you need to do and doing your job like you're supposed to be doing. I wanted to just throw that out there, that you guys are doing excellent and keep up the good work. We got one test down, so we don't have too many more throughout the whole year. So today we're going to start the second part of Unit 1, which is all about exponents. Now, we used a little bit of exponents when we were talking about roots, but today we're going to learn some exponent rules. And today there's two in particular we're going to talk about, okay? So just to kind of start you off here, when we have an exponent, this number is called the base. All right, the base is any number that could have or does have an exponent on it. And obviously this is the exponent. We know that 4 to the third power means that I want to multiply 4 by itself 3 times, right? So the base number this many times. The exponent tells me how many times I need that number. And so there's some things that we can do to simplify some operations. So for example, let's say we had something like 2 to the third times 4 squared. You probably remember this from before, but we would use order of operations, right? And we'd have to do the exponents, right? Please excuse my dear Aunt Sally, or PEMDAS, or however you learned that. We have to do the exponents first. So I'd do 2 times 2 times 2, figure out what that is. I'd do 4 times 4, figure out what that is. And then I'd multiply those two things together because multiplication comes after exponents. But there are some special rules that we can learn about to help us simplify what we're doing here. All right, so we're going to talk about those. First one we're going to talk about is the multiplication rule. And the multiplication rule says that when I multiply two numbers with the same base, so they have to have the same base, I can keep the base and add the exponents. Yeah, so the multiplication rule says that when I multiply two numbers with the same base, it only works when I'm multiplying. It only works if two numbers have the same base. But if they do, then I can use this rule that says that I would keep the base and I would add the exponents instead. So for example, if I had something like 5 to the 8th times 5 to the 5th, that's going to be a really, really big number, right? I don't even want to put that in my calculator. It's probably going to be so big. But what this rule says is, since these are both 5s, right, since our bases are the same, what I would do is, instead of having to worry about doing any math whatsoever, I can simplify this and keep the base. But I'm going to go to these exponents and I'm going to add those two things together to give me my new exponent of 13. So whatever 5 to the 8th times 5 to the 5th is, it's going to be the same thing as 5 to the 13th. And if you want to know why that's true, right? Really think about what we're doing here. This means 8 fives. 1, 2, 3, 4, 5, 6, 7, 8. Some of those are not very pretty. This means multiply that by 5 more fives. 1, 2, 3, 4, 5, 6. And then really what we have is 13 fives. So as long as the base is the same, that's going to work for all things when we multiply. So there's quite a few of these I want to show you. Sometimes our bases are going to be variables. So for example, what if I have x to the 6th times x to the 4th? Well, it's the exact same idea, right? Our bases are the same. I can use the multiplication rule because we're multiplying them. So the multiplication rule says keep the x, take your exponents, and add them together. So whatever x to the 6th times x to the 4th is going to be x to the 10th. What if a number doesn't have an exponent? Does a base have to have an exponent? Because this one doesn't. Well, just like most things in math, boys and girls, if you don't see something there, how many 7s are actually in this part right here? 1. So if it doesn't have an exponent, that means it always would have an exponent of 1 there. Okay? So you can write a 1 in, you can just know that it's 1, but there's literally 1 7 here, right? There's 8 7s here, there's 1 7 here. So this would be, keep the base, 8 plus 1 would be 7 to the 9th power. All right, let's throw a little curveball in. What if I gave you this one? 5x to the 4th times 3x squared. They say, Mr. Odie, you said the multiplication rule only works if numbers have the same base. That's true. However, 3 and 5 are not the same base. But you know what is? X and x. So this time we can use it for part of the problem. Not all of it, but part of it we can use it. So we can use our multiplication rule for the x's here. So we're going to keep the x, add their exponents, and then what are we going to do with 5 and 3? Well, don't forget what kind of problem it is. Right? It said multiply. So with 5 and 3, who are not like terms, they are not the same base. They are like terms. But they don't have the same base. We can just do what the problem says. In this case, that's multiply. So we can simplify this one to 15x to the 6th. We use the multiplication rule for the x's, and we just do multiplication for the other numbers that don't have the same base. We could do that with numbers, a lot of variables, like this. 4a squared b to the 4th c to the 3rd times 3a b to the 8th c to the 6th. Now it's getting crazy up in here, right? So our same idea. We're going to use our multiplication rule. That means we got to keep these bases that are the same. So 3 and 4 are not the same base. The a's, however, they do have the same base. So there's 2 of them here, there's 1 of them here, because there's nothing there. So we add those, that gives me a to the 3rd. Do it with the b's. Keep the b, add them up. 8 plus 4, there's 12 total b's. Do it with the c's. Keep the c. 3 plus 6 will give you 9 total c's. And then with the 3 and the 4, again, they don't match, so we do whatever the problem says and multiply them. 3 times 4 is going to give me 12, a to the 3rd, b to the 12th, c to the 9th. Basically, that's how the multiplication rule works. All right, I tried to give you kind of different examples of things that you're going to need to know, things that you'll see. Just make sure you're looking for the same base. Those are the ones we can combine, right? All right, what about the division rule? The division rule works very similarly. All right, in fact, it sounds almost the same as the multiplication rule, because we're going to say if you divide two numbers with the same base, you can keep the base, just like in multiplication, but this time we're going to subtract the exponents. So if I'm dividing two numbers with the same base, I'm going to keep that base and I'm going to subtract. When we talk about subtract, it's always top minus bottom. And that's super significant because we can have negative exponents that we'll talk about later in the week. All right, so it's going to be top minus bottom. So, for example, if I had 8 to the 4th divided by 8 squared. Again, I could put both of those in my calculator, figure out what they are, and then divide them and figure out what this answer is. But it's going to be easier for me if I just use a simplification rule. So I can use it because they're both 8s, and the rule says that I keep the 8, and I just subtract the exponents. So 4 minus 2, that's going to leave me with only 2 8s. You might say, Mr. Odie, why does it leave you with only 2 8s? What a great question. This is just 8 times 8 times 8 times 8. I'm not going off screen, am I? Oh, no, we're good. This one down here is 8 times 8. We learned about division with fractions earlier, like in 5th grade, that those would cancel each other out because they're on the top and bottom. And those would cancel each other out. So how many are we left with? Just the 2 that we have. That's why the division rule works. So it's going to be very much like the multiplication rule, only now we're going to subtract exponents. The way that I remember these, if it helps you guys, that's great. If not, you can come up with your own. Multiplication, numbers get bigger. That's how I remember I add. Because when I add, numbers get bigger, generally speaking. Division rule, division, things get smaller. When I subtract, things get smaller. So when I divide, I subtract. When I multiply, I add. Let's take a look at what those are going to look like. Let's say we have z to the 18th divided by z to the 11th. I got 18 z's on top. I got 11 z's on the bottom. Since they're both z, I can use the division rule, which says keep the z, subtract my exponents. So those will simplify to z to the 7th power. What if I have a number out in front like we did on multiplication rule? So what if we had 36a to the 8th divided by 4a cubed? Okay, the 36 and the 4 do not have the same base. We're not going to use the rule on those, but the a's do. So we can use the rule on the a's. I can keep the base, subtract top minus bottom, 8 minus 3. I'm going to have 5 a's left. What about the 36 and 4 that don't have the same base? Well, we're going to do whatever the problem says. In this case, we're dividing. So I'm going to do 36 divided by 4. And my final answer is going to be 9a to the 5th. Pretty much the same, except the exact opposite, right? I think you know what I'm saying. Hopefully. Golly. What about f to the 10th, g to the 9th, h to the 15th, all over cubed g h to the 13th. Okay? Again, we're only going to match up stuff that has the same base. So I can simplify the f's, right? Here's an f, here's an f. 10 minus 3, that's going to give me f, keep the base, to the 7th power. Work with the g's. They both have a g, we keep the base. 9 minus, what's really on this g? Really a 1. 9 minus 1 would give me g to the 8th. Now I got h's. 15 minus 13, we keep the h. That's going to be 2 h's left. Ooh, I just thought of one I wanted to show you. Okay, not that that one wasn't exciting. But I'm going to try to wrap this up because I don't want it to get too long. But I just thought of this one. What if I did x to the 8th, z to the 11th, over x squared, y squared, z squared. Yeah, this is a good one. People get tricked by this one. Yeah, this is good. Okay, check out the stuff that has the same base. The x's do, I can use the division rule. Keep the base. 8 minus 2 is going to give me 6 x's. Notice that the y's don't have one on the top and bottom. They don't match up. So we don't use the rule with y. Let's keep going to z. Here's one on top, here's one on bottom. We're dividing them. They're both the same. So we keep the base. 11 minus 2 is going to give me z to the 9th. What do we do with the y? There's nothing to divide it by. It doesn't match up. We can't use the division rule. We leave it. Leave it how it is. So if you're looking at this y, what can you tell me about y? Hopefully at home you're thinking, well, it's on the bottom, Mr. Odie. Guess what? We're going to leave it on the bottom. So over here in my answer, I'm just going to leave the y exactly how it is, exactly where it is. Okay? That one gets people. I'm just going to warn you right now. That one gets people. Okay. That's multiplication rule and division rule. This week, my goal, we're going to learn about power to a power. We're going to learn about negative exponents. And then we're going to do a lot of practice with these. Because even though it's only 4 rules, it seems like it always is like very tricky to kids. Okay? Ooh, 18 minutes. This is like the longest video yet. You guys get extra Mr. Odie time today. Lucky you. All right. Have a great rest of your day.